Firewall concepts. In this nugget, we're going to discuss the firewall concepts that make up the network security world as we know it today. We will cover the following topics as part of this discussion. We will cover the OSI model and an overview of exactly what the OSI model is and what each layer of the OSI model represents to us. And then we will talk about the types of firewalls that are supported through our checkpoint security solution. So let's discuss, what exactly is a firewall? Well, if you were to actually poll 9 out of 10 people who are not in the network security industry, they may tell you that a firewall is the wall that separates their apartment from their neighbor's apartment just in case a fire was to break out. And they may also tell you that it's the compartment on their car that separates the engine compartment from the interior cabin. Now, we all know that the world of network security firewalls has really grown in a rapid fashion in the last 10 to 15 years. So let's get into the actual OSI overview, where we're going to talk about the actual OSI model and what it means to you and why it's really important in the world of network security and the networking industry as a whole. OSI model. Well, what is this? This is exactly a chart to describe the world of computers as we know it today. Well, it looks kind of simple. Not so flashy, not so complicated, but it's actually how things work today, and it's how the network world and the hardware world come together to make an actual application work for us. And this is the 7 layers that represent the OSI model. Alright, so let's discuss each one of these layers at this point to help you get a good understanding of exactly why we need the OSI model. Now, to actually get into the world of network security and firewalls, it's very helpful to understand what exactly the OSI model or the Open Systems Interconnect model can do for us. It's meant to represent an actual graphical depiction of how everything works in the world of network security and networking in general. The first layer that we have here is our physical layer. And then we have our data link, our network, transport, session, presentation, and application layer. Now, whenever you see this, and one of the first things that you're going to need to do as you get into the world of network security and the world of networking in general is to memorize this layer and to be able to recognize exactly what applications and what type of devices fall in the different layers of the OSI model. So your first job is to remember all 7 layers. And the easiest way to do this is to remember a couple sayings. And the first one is, all people seem to need data processing. Or my favorite, please do not throw sausage pizza away. So very simple. If you can remember one of those terms and to be able to recognize that layer 7 is application, layer 6 is presentation, layer 5 session, 4 transport, 3 network, 2 data link, and 1 physical, and a posture and a pear tree. But anyway, let's get into exactly what goes on in layer 1. So layer 1 is actually the physical layer. And layer 1 is actually going to be representative of actual physical hardware. You can touch it, you can hold it in your hand, you know exactly what something physical is. And the physical layer is where we're going to describe and where we're going to be able to understand that is exactly where an Ethernet card, a hub, a actual cable that you can hold exists at in the OSI model. And it's exactly where everything starts, because you can't get any communication on a network until we complete exactly what's going on at the physical layer, because we're going to have that network card in that computer, and we're also going to have that network Cat5 or Cat6 cable connected to that port, and that's going to run to the data port on your wall, or a hub, for example. And that's the first thing we need to understand, is the physical items that make up the base level of computing, and that's what goes on at the physical layer. And our next layer of discussion is going to be the data link layer. So what is the data link layer? Well, the data link layer is going to represent where the network traffic is delivered to the local area network, and this is where identification of a single machine is going to take place via MAC address. So you may have heard the term MAC address, and what a MAC address is, it's essentially like a social security number for computers and network devices. Pretty much every manufacturer that's out there is going to issue a unique MAC address to each of their devices that exist in the data link layer, for example. And an actual example of a piece of hardware that works in the data link layer is a switch. A basic network layer switch, layer 2 switch we should say, and you may hear the term layer 3 switch in your world of network security and networking at some point, but we're just talking about a basic switch that you can buy and you can put on your desk and hook up 2 or 3 machines, and you don't have to get in and configure it or anything. You just plug it in and it works. That's basically what a regular switch is going to be, and that's what's going to exist at the data link layer. And this is definitely where we're going to have to encapsulate all of our information inside of a MAC address to get common machines uniquely identified and get them accessible on the network. So let's see a MAC address and let's see exactly what it's all about. So we're going to open up our actual configuration here, and let's log back in one more time. It appears that it has locked us out, and now that we're logged back in, let's see exactly what a MAC address is all about. So once we get into our TCP/IP settings and we enter the DOS window or the command line, for example, and we're going to issue an IP config /all, and you can do this on your own machine, and it's going to show us our actual MAC address. And like we said, the physical address on our machine is going to be this right here. So if we mark this, that is our MAC address. This is exactly where we're going to take this machine and put it on our network and connect it to our switch, and it's going to be uniquely identified by its MAC address. So that's essentially what the MAC address and the layer 2 of the data link model is all about, and why it's very important inside the world of network security and the world of networking today. So let's get into our next layer of discussion, and that is going to be the network layer. So let's talk about the network layer. So what is the network layer and what is it all about? Well, the network layer is going to be where you identify machines in the world of IP telephony today, or in the world of networking or network security today. Everything that exists on an actual network or on the internet, for it to be accessible to our computers, must have an IP address. So addressing in this layer is covered by an actual IP address. So you might understand that we have the concept of public and private IP addresses that we're going to discuss as part of this series, but this is exactly where we identify how machines are accessible on the internet. And an example of a physical device that would exist in this layer is a network router. So if you had a Cisco router, this would be a good representation of a device that exists at layer 3 of the OSI model, and that is the network layer. So let's discuss the transport layer. So what is the transport layer and why is it good to us? Well, the transport layer is going to describe two of the most important protocols in the world of networking today and the world of security today. And that is the Transmission Control Protocol, or TCP, and the User Datagram Protocol, or UDP. Now, the main difference between these two types of protocols are the actual reliability and the speed that exists between the two. A Transmission Control Protocol, or TCP, is a connection-oriented protocol, meaning that it cares about the connection. It'll actually try to rebuffer itself and to ensure that we delivered packets on an application or on the network without errors. So Transmission Control Protocol has the concept of error correction, and it's going to make sure that it gets an acknowledgement and that it ensures a packet arrived at its destination. And the next type of protocol is the UDP packet. Now, the UDP packet is a connectionless protocol, and it basically is going to be used in a lot of devices where you can drop a few packets and you're going to be okay, such as a video stream or voice over IP or anything that's pretty much real time and streaming is going to use a UDP packet, and that's going to be defined at the transport layer of our OSI model. Now, one concept that comes very important at this layer is the concept of statefulness. A stateful firewall, as we will see, is going to be defined at the transport layer, where it actually has the ability to look at the entire structure of a packet, but we're going to get into that. So that's the main things that we need to understand for the transport layer, and two of the main protocols that we need to understand exist at layer 4 of the transport layer for TCP and UDP. So what is the session layer all about? Well, the session layer is important as well, and the session layer is going to establish and maintain end-user sessions across the network. It's responsible for providing synchronization of services by planting checkpoints in the data stream, and if the session fails, only data after the most recent checkpoint need to be retransmitted. And it manages who can transmit data on the network at a certain time. And some examples of some common protocols that you may have heard of that exist at the session layer are NetBIOS and remote procedure call. So that's the main thing that we need to understand. The session layer is going to understand how sessions are going to exist on the network, and it's going to manage that whole conversation that's going to happen between two computers. Presentation layer. So what is the presentation layer all about? Well, the presentation layer is going to translate application to network format and vice versa. So as an application needs to talk to the network in order to send that information out of our firewall, for example, we're going to have to rely on the presentation layer to present that type of data to the lower layers in the OSI model. So from the application, it's going to go to our presentation, and this is going to present the data to the lower layers and convert things in the application across the TCP/IP stack in order to get them sent across the network. And it's definitely going to be responsible for protocol conversion, character conversion, and it's also going to set standards for different systems to provide seamless communication for multiple protocol stacks. So that's the main thing we need to understand, that the presentation layer is going to present the data to the lower layers of the OSI model so that it may act on that type of data and get it moved across the remainder of the OSI stack. Alright, so we've arrived at the layer 7, the king of the mountain, the application layer. The application layer is going to be used for applications specifically written to run over the network. It's going to allow access to network services that support these applications, and some examples of some common applications that you are very familiar with that exist at this layer are DNS, FTP, TFTP, BootP, SNMP, SMTP for mail traffic, Telnet, and SMB for Microsoft shares or things like that on a Windows network, for example. Now, the application layer is pretty important in the world of network security, and this is where one of the strongest aspects that make Checkpoint the network security leader that they are exist is in their application gateway or the application layer gateway through a product called Smart Defense. Smart Defense is going to provide you the ability to do some protocol validation to ensure that an HTTP packet is really an HTTP packet. Now, there's a common exploit that a lot of attackers have gotten into these days of actually trying to mask different types of attacks behind protocols that we typically have to leave open on our firewall. In order for our companies to operate, we have to leave our email port open, and we may need to leave a web server port 80 or port 443 open. So there's a lot of attacks that are going to use those common ports and try to come through those ports looking like legitimate traffic when it's actually an exploit on the network. And that's one of the main things that we need to understand at the application layer. We get into the application layer gateway firewall concept, and that's going to be very important as we get into our nuggets specifically on smart defense. But that's the main thing I wanted you to understand about the application layer, is where our common applications are presented to us. It's the things that we can see and touch and click on a computer, and then once we actually open that email or send an email or ping that server, those type of things are going to come up at our application layer and then move downward through our OSI model to get this type of communication out to our host that we want to talk to. So that's the main thing that I want you to understand, that these 7 layers of the OSI model make up the world of networking today, and it's very important for network security as we know it today. So the last concept I want to leave you with is, where does Check Point fit exactly into this model with their firewall products? Well, the point that you need to understand, whenever a Check Point firewall injects itself into this model, it's going to be right here. And that's exactly where we're going to have a firewall kernel. So where is that exactly? Is it in the data link? Is it in the network? No, it's actually in between. That is exactly where Check Point is going to inject its kernel to watch as traffic comes from the physical layer through the data link, and before it actually gets to that network layer where it could be presented to computers on our network. That is where the Check Point actual inspect code and the kernel for our firewall is going to exist. And that's an important point that you need to remember for your CCSA concepts and objectives. So with that, let's move on to our next point of discussion, and that is the OSI model. Alright, so I hope you're ready. Let's dive into the firewall concepts and technologies that are supported by Check Point. Now, the first type of firewall technology that Check Point is going to support is a very basic level of firewall, and in general, is the packet filter firewall. Now, the packet filter firewall is going to be firewall in its most basic form. And it's going to function at layer 3 of our OSI model, and it's going to basically filter traffic based on 5 factors. And those 5 factors are based on the source address, the destination address, the source port, the destination port, and the protocol. And those are the 5 things that a packet filter firewall are going to look at when it decides to make a decision on how it's going to accept or deny a packet. Now, the main thing that we need to understand about a packet filter firewall is that it is the least secure type of firewall, because it has no intelligence to look and to ensure that a SMTP packet is really an SMTP packet. It has no intelligence, we should say. And that's the main thing we need to understand about a packet filter firewall, is though it's very basic, and it's exactly where we all started from, and it still has a limited importance in networking today, but is the basic layer that you need to have on all firewall products before we move into the next type of firewalls, and that is stateful inspection. Stateful inspection is very, very critical and very important to networking today. Stateful inspection is going to give us the ability to examine the entire packet. It's going to look at the header all the way to the actual end of the packet to make sure that the packet is as it says it is, and it's going to have statefulness. And that's where the actual stateful inspection becomes very important. And this technology was developed and patented by Check Point back in 1993, or a little bit before, 92 maybe. The Check Point actually came up with the concept of the stateful inspection firewall, and they were the ones that patented this technology and made it what it is today. And that is one of the reasons why Check Point is so successful and who they are in the world of network security. And we need to understand that a stateful inspection firewall is going to exist at layer 4 of the OSI model. So if we remember, if we go back to our actual saying, we see all people seem to need data processing, right? So the T represents the transport layer. So the transport layer is where our stateful inspection is going to take place. And like we said, it's going to examine the entire packet, and it's definitely going to provide some application intelligence to verify that a packet is as it appears to be. And that's one of the main things that we're going to get into as we get into our smart defense discussion, as I talked about later on in this series. But that is where application intelligence kind of comes together with the stateful inspection to make up the wonderful world of checkpoint firewalls today. So there's basically 3 layers that a checkpoint firewall is going to use. We're going to use a packet filter, we're going to use stateful inspection, and we're going to use an application layer gateway through protocol validation presented by the Smart Defense product to make your environment totally secure. And the next concept that I want to get into is the concept of a bridge mode firewall. A bridge mode firewall is some really, really cool stuff, and we're going to take a look at that in depth here. Now, a bridge mode firewall is going to be invisible to all layer 3 traffic. So what does that mean to you? If we go back to our OSI model and we talk about layer 3 is where IP addresses are defined. So, kind of to throw the whole concept of things need to be on this type of network to talk to each other using IP addresses, it's not always true in the aspect of bridge mode. Now, bridge mode is going to be completely visible to all layer 3 traffic, as we said, and all traffic is basically going to be passed from one interface to another across a layer 2 relationship across a bridge, which is common to our data link layer of our OSI model. And it's going to correct routing limitations on the network. Now, it is not always possible whenever you want to implement a firewall technology to change the routing of a network. So let's say, for example, you have one network right here, and we have another network right here. And in between these 2 networks, we want to implement a firewall. So typically we'd have to put the firewall here, and we'd have to have an IP address for this network right here, and an IP address for this network right here. With a bridge mode firewall, we have the ability to put this in place, plug in an interface from each of these networks, and have it be completely invisible and very stealth mode like to the people on each of these networks. But we can also enforce network security policies across a bridge mode firewall, but we will need to have one interface that is accessible via a layer 3 IP address for management or to push policy to the firewall. So if this was our actual smart center down here, our smart center would need to talk to an actual interface on that bridge mode firewall. So let's take a look at bridge mode firewalls as they exist today. So let's talk about some concepts of the bridge mode firewall that we need to know about. Now, a bridge mode firewall is going to have a few restrictions. A bridge must be configured with a pair of interfaces, as we said. Cluster configurations are not supported on a bridge mode firewall. Network address translation is not supported. In order to manage the gateway in a bridge mode, as we stated, we're going to need an interface with a layer 3 IP address in order to get that type of connection available so we can push policy toward our firewall and have SIC in place for secure internal communication. Now let's get into configuring bridge mode on our checkpoint firewall just so you understand exactly what it is and how it's actually configured in the network of checkpoint. So let's do this. What we're going to do, we are going to actually use a putty session to get over to our Nugget firewall, for example. So let's open this up, and we're going to load up our Nugget firewall, and let's open it up, and let's log in and authenticate. Now, if you have the need to implement a bridge mode firewall in your network, I do recommend that you do some checking to make sure that it's going to be compatible with the current hardware that you're using. And one of the things that have to be in place is the concept of the MII, or the media input commands. So these type of things have to be working on your particular firewall for the bridge mode to work correctly, from my experience of trying to use bridge mode in our Checkpoint R65 product, for example. So if we issue a MII-tool command, and if you get these type of information right here where it's saying that this isn't available or it failed, it's a good idea that the bridge mode isn't going to work in that configuration. But if you need to do this, a actual hardware device with properly recognized network interface cards are going to need to be available, and you're going to see information that says that this particular interface is up, that the link is up, that it's being recognized, and that it's going to be accessible for doing bridge mode. But let's look at the actual bridge mode config. So we're going to issue a sysconfig. On the sysconfig, we're going to choose option number 5 for network connections. Under network connections, we're going to hit option number 1 for add a new connection. And then we're going to see the aspect of number 3 for the bridge. So, with the bridge, it's going to ask us the bridge the following interfaces and then hit end for next. So, let's go ahead and take a quick look at this. Now, it may not let us do all this, but let's just see what it looks like for now. So, if we hit option, it says configurations or change your choice, so let's hit option number 2. It says fail to add interface ETH1 to bridge. Please remove its IP address before adding it. So that gets into the concept I was talking about. Layer 3 is not accessible. We throw layer 3 out the window. So for an actual bridge to exist, we're going to have to configure this type of information without IP addresses on the interface. So we're going to have one interface, like we said, to get into the box for management and to push policy and for secure internal communication of that firewall. But we're going to have no IP addresses on the two interfaces that are going to exist in the bridge. But that's one of the main concepts I wanted you to understand, is that it's completely a layer 2 relationship. So let's go ahead and hit enter to continue. Let's do E to exit, E to exit, E to exit, E to exit. And let's run a clear. And let's look at a couple commands here that are kind of important to the actual bridge concept. So if we do brctl space show. Alright, so this is what we would see. If we had a bridge set up on our checkpoint firewall, we would see some information here that would give us our bridge name, our bridge ID, whether spanning tree protocol is actually enabled, which prevents loops in networks, and is common in the network switches from Cisco and the other vendors. So spanning tree protocol is actually supported through checkpoint for a couple different technologies of spanning tree. Now it's going to basically just make sure that we eliminate undesirable loops between switches, and then we will be presented with the actual interfaces that make up that bridge. So if we have ETH0 or ETH1, those type of interfaces would come together and be part of that bridge. So that's the main concepts I wanted you to understand, that a bridge firewall is accessible, is usable in the checkpoint world, and it's very powerful if you need that type of technology and you can't change the routing, or you want to be very stealth-like in your approach, that you want to implement this without people knowing about it. That way you can see exactly what type of traffic is going across that link and be able to develop a security policy that's going to allow you to take a look at exactly what someone is doing and be able to enforce policies on top of that connection. So that's the cool thing about bridge mode. In this nugget, we covered firewall concepts. We dived into our OSI overview where we discussed the 7 layers that make up the OSI model. So it's very important to take from this that you understand what all 7 layers are, how to describe each of them. We want to memorize all 7 layers. We want to understand which protocols and types of information are going to exist at all 7 layers of our OSI model, and it can really help you in your troubleshooting efforts. That way you know to look for physical connectivity, and then you're going to look for a layer 2 relationship based on the MAC address, and then a layer 3 relationship based on the IP address, and then we'll move up from there into the transport and session and presentation up to the application layer. And then we talked about the actual concepts of the types of firewalls that are supported on our checkpoint firewall solution, where we talked about an actual packet filter firewall, and then we moved into a stateful inspection firewall. We talked about protocol validation as part of the Smart Defense product that's going to make up an application layer gateway type firewall, and we looked at bridge mode firewalls. So I hope this has been informative to you, and I'd like to thank you for viewing.